So we are going to be learning sine rule and cosine rule to calculate the length and angle for in triangles that are non-90 degree. So the trigo that you already learned so far, all this, so the one that you learned in Sec 2, also meant to calculate length and angle, but it will happen in right angle triangle. So in Sec 3, right, you are learning these two rules to calculate length and angles in non-90 degree triangle. Okay, so you don't die need to look for the 90 degree. Okay, the sine rule is a very simple one if you look at the formula. The sine rule is a very simple one if you look at the formula, and actually a lot of students like that formula. So we stay with the same notation like what we did last week. Capital letter stands, I think I wrote it wrongly. Capital letter stands for angle, small letter stands for length. Okay, correct. A bit like haven't wake up. Okay, so the sine rule is one of the favorite because, right, you just need to arrow, and one arrow will form one fraction. So a lot of students like sine rule. Okay, because like one arrow, one fraction. So another arrow, another fraction. So that is sine rule already. Okay, please sign the angle. A lot of people, sometimes, right, I don't know what they are doing. They will sign a length. When we do sine, cosine, tangent, right, you are doing it on the angle, not length. Okay, so one arrow, one fraction. So that's why this formula is one of the favorite for students. It's very easy to remember. I don't need three fractions. I just need two of them. Then I can go for the cross multiplication. So later on, I will show you through a numerical example. Okay, so one arrow, one fraction, that will have given you the sine rule. So the sine rule can be tilted the other way around. It can be, instead of A over sine A, it can be sine A over A. It can be sine B over B. So you can flip it around, but be consistent. Okay, so whichever direction that you like, you can just decide for yourself. Okay, so this is one of the easiest formula because it's just one arrow equal to one fraction. So very easy to remember. But you try to use this only in a non-right angle triangle. So if it's right angle triangle, it will still be preferred that you go back to your usual trigo ratio. Okay, so try to like section your brain in this way. Right angle, I still go back to my Sec 2 work. If it's non-right angle, then I will go to this. Okay, don't keep using the sine rule because it's your favorite. You know, when you like to eat something, you will just keep eating it, right? So when you like a formula, sometimes you feel that it's easy to use, you will keep using. So it's not advisable in this situation. You will lose out when the question become very long. Okay, or you tend to overthink a simple question. Okay, so this one will be one of the easiest formula, sine rule. Okay, later on I will show both situations, like how will you find length or angle. But in sine rule, right, there is an ambiguous case. So Frederick, there's an ambiguous case. Later on, there is one example that particularly addressed the ambiguous case. So Jaron, if you have learned it in school, your teacher would have told you about the ambiguous case. So that one is a case that you will need to take note. So later on, there's an asterisk example. Okay, so one arrow, one fraction. That will nicely summarize sine rule. The cosine rule is not so friendly. The cosine rule is not so friendly. Okay, so for the cosine rule, right, This one is optional. Just stay with this. Okay, so I'm going to explain to you, right, the structure of the cosine rule. So just now, right, the structure of a sine rule is one arrow, one fraction. Okay, so in this cosine rule, I only need one arrow. Okay, essentially sine rule need two arrows. So two arrows then can give you two fractions to cross multiply. So if I'm going to be doing the cosine rule, I want you to take a look. Okay, look at the arrow, angle A and A. It will form something like this. Okay, so can you see the arrow? The arrow is arrow the angle and the length, correct? So this is how I'm going to form my cosine rule. I'm going to form my cosine rule with a fake Pythagoras theorem. Okay, why do I call it a fake Pythagoras theorem? Because it is not a right angle triangle, but it looks a bit like Pythagoras. So it looks a little bit like a Pythagoras. So it looks like a Pythagoras. You subtract 2BC bracket cosine A. So you form an arrow and then you have a thick Pythagoras in between. Then you minus 2BC multiplied by cosine A. So all these are multiplication. Okay, so that is the cosine rule. So most people will find cosine rule challenging. If you use cosine rule in O level, right, you will get 3 marks. So if you calculate a length or you calculate an angle using cosine rule at O level standard, that will be 3 marks. Okay. So I'm going to repeat this whole thing again with another arrow. So Jaron should have learned this in school. I'm not very sure because you mentioned something about learning this formula. Okay, so I'm going to erase off the arrow for A. So I'm going to, now I'm going to arrow B. So now I'm going to arrow B. I'm going to start off with B squared. And it will be a cosine B. I'm going to start off with B squared, and then that will be connected to the cosine B at the end. So in between, you do a fake Pythagoras again. Can you see the structure? So in between, you do the fake Pythagoras. You subtract off 2AC bracket with cosine B. And all these are multiplication. Frederick got kicked out. Make sure you can hear me, Frederick. So Frederick, just now I was saying, right, the sine rule, there's an ambiguous case. So one of the example is asterisk. So if you're not very sure about the ambiguous case later on, you just take note. Okay, I will be going through the example. So for the rest of you, right, cosine rule is harder because it's quite long. And there is a way to remember, use the arrow to remember. So you use the arrow and you use the fake Pythagoras. Okay, so again, I'm gonna arrow it another way around. So I'm gonna arrow C. So if I'm going to arrow C, then it will be a C square. And it will be connected to cosine C. Then you form the fake Pythagoras theorem. And then you subtract away 2AB. Frederick, let me know which example are you at. Huh? So that is the cosine rule. So the cosine rule will be helping you to calculate length and angle. So some students will be like, when these two formulas are being mixed during exam, some students will be confused. So when do I use sine rule? When do I use cosine rule? So there is a specific way, but I usually use arrows. So if the question has 2 arrows, I will use sine rule. If the question only get 1 arrows, I will use a cosine rule. Okay, so 1 arrow cosine rule, 2 arrows, because 2 arrows can form 2 fractions, and I will do a sine rule. So that is the introduction on the 2 formula before I show you numerical example.